Here certain information will be brought to you about some from the German company Festo that act like animals. Festo is a top brand of German multinational industrial control and automation company based in Esslingen am Neckar, Germany. Since 2006, Festo has been building animal-like robots as part of its Bionic Learning Network. Mimicking the efficiencies of the natural world is meant to help researchers come up with more creative and efficient ways to improve manufacturing. Today, we are going to tell you about 7 types of these robots. Number 7. Bionic Kangaroo. The kangaroo robot at the core of the bionic kangaroo is a mechanism of repercussion. It uses the energy recovered from one jump to help it make another. Real kangaroos quickly get tired and could not jump for a long time without this mechanism. Springs that store mechanical energy on the landing and give it away on the next jump are used in this project. The robot is controlled by a special bandage that reads myoelectric signals from the human forearm. A bionic kangaroo that weighs 7 kilograms and height 1 meter can make a jump of 80 centimeters in length and 40 centimeters in height. Number 6. Bionic Flying Fox. Festo calls their Bionic Flying Fox an ultra-lightweight flying object with intelligent kinematics. For the Bionic Flying Fox, the developers of Festo, from the Bionic Learning Network, took a close look at the flying fox and technically implemented its special flying characteristics. Due to the combination of the integrated onboard electronics with an external motion tracking system, the ultra-lightweight flying object is able to move semi-autonomously in a defined airspace. Number 5. Bionic Fin Wave. The marine planarian, cuttlefish and Nile perch have one thing in common: in order to propel themselves, they use their fins to generate a continuous wave, which advances along their entire length. With this so-called undulating fin movement, the bionic fin wave also maneuvers through a pipe system made of acrylic glass. At the same time, the autonomous underwater robot is able to communicate with the outside world wirelessly and transmit data, such as the recorded sensor values for temperature and pressure, to a tablet. Number 4. Bionic Wheelbot. The biological model for the Bionic Wheelbot is the Flick-Flack spider. It lives in the Erg Chebbi Desert, on the edge of the Sahara. Professor Ingo Rechenberg, a bionics professor at the TU Berlin, discovered it there in 2008. The Flick-Flack spider can walk like other spiders. It can also propel itself into the air, however, with a combined sequence of somersaulting and rolling on the ground. So like its biological model, the Flick-Flack spider, the Bionic Wheelbot can both walk and roll. In rolling mode, the Bionic Wheelbot does a somersault with its whole body, just like the real Flick-Flack spider. The robot has an inertial sensor, so it always knows what position it is in and when it has to push off again. It is therefore much faster when rolling than walking and can even overcome inclines of up to 5% uphill. Number 3. Bionic Swift. They are agile, nimble, and can even fly loops and tight turns. The 5 artificial swallows can move in a coordinated and autonomous manner in defined airspace by interacting with a radio-based indoor GPS. When designing the robotic birds, the focus was on the use of lightweight structures, just like their biological role model. Number 2. Bionicopter. Festo has technically mastered the highly complex flight characteristics of the dragonfly. Just like its model in nature, this ultralight flying object can fly in all directions, hover in mid-air, and glide without beating its wings. The wings consist of a carbon fiber frame and a thin foil covering. The intelligent kinematics correct any vibrations during flight and ensure flight stability. Number 1. Festo Bionic Ants. Like their natural role models, the bionic ants work together under clear rules. They communicate with each other and coordinate their actions and movements among each other. The artificial ants thus demonstrate how autonomous individual components can solve a complex task together, working as an overall networked system. Each ant that is 13 centimeters long has on its belly a radio module through which precise coordination is carried out. A 3D stereo camera in the head of the ant allows it to see, and the infrared optical sensor installed below monitors the movement of the mini robot. Meanwhile, 2 onboard batteries provide up to 40 minutes of wireless ants work, and they are recharged in the dock with the help of their antenna.